Learning classes and objects. When you think in object-oriented manner, everything is an object, and every object is a member of a class. You can think of any inanimate physical item as an object. Your desk, your computer, and the building in which you live are all called objects in everyday conversation. You also can think of living things as objects. Your houseplant, your pet, fish, and your sister are objects. Events are also objects. The stock purchase you made, the mortgage closing you attended, and the graduation party that was held in your honor are all objects. Everything is an object, and every object is a member of more general class. Your desk is a member of the class that includes all desks, and your pet fish is a member of the class that considers all the fishes. An object-oriented programmer would say that your desk is an instance of the desk class and your fish is an instance of the fish class. These statements represent an is a relationship. That is, relationship in which the object is a concrete example of the class. Expressing an is a relationship is correct only when you refer to the object and the class in the proper order. You can say, my oak desk with the scratch on top is a desk, and my goldfish named Moby is a fish. You don't define a desk by saying, a desk is an oak desk with a scratch on top, or explain what a fish is by saying, a fish is a goldfish named Moby. Because both a desk and a fish are much more general, the difference between a class and an object parallels the difference between the abstract and concrete. An object is an instantiation of a class, or one tangible example of a class. Your goldfish, my puppy, and Zoo's shark each constitute one instantiation of the fish class. The concept of a class is useful because of its reusability. Objects gain their attributes from their classes, and all objects have predictable attributes because they're members of the certain classes. For example, if you're invited to a graduation party, you automatically know many things about it. You assume there will be a starting time, a certain number of guests, and some quantity of food. You understand what a party object entails because of your previous knowledge of the party class. You don't know the number of guests or what exact food will be served at this particular party, but you understand that because all parties have guests and refreshments, this one must too. Because you understand the general characteristics of a party, you anticipate different attributes than if you plan to attend a theater performance object or a dental appointment object. In addition to their attributes, objects have methods associated with them. And every object that is an instance of a class is assumed to possess the same methods. For example, for all party objects, a date and time are set at some point. In a program, you might name the class methods set date and set time. Party guests need to know the date and time and might use methods named getDate and getTime in order to get those values. Method names that begin with get and set are very typical. You will learn more about get and set methods in this video. With object-oriented programming, sometimes you create classes so that you can instantiate objects from them, and other times you create classes to run as applications. Application classes frequently instantiate objects that use the objects of other classes and their data and methods. Sometimes you write classes that do both. The same programmer does not need to write every class he or she uses. Often, you will write programs that use classes created by others. For example, many programs you have seen so far in these series of videos have used the system class. You did not have to create it or its println method. Both were provided for you by Java's creators. Similarly, you might create a class that others will use to instantiate objects within their own applications. You can call an application or class that instantiate objects of another class a class client or a class user. Now let's talk a little bit about creating a class. When you create a class, you must assign a name to the class, and you must determine what data and methods will be parts of the class. Suppose you decide to create a class named employee. One instance variable of employee might be an employee number, and two necessary methods might be a method to set or provide a value for the employee number, and another method to get or retrieve that employee number. To begin, you create a class header with three parts: an optional access identifier, the keyword class, and any legal identifier you choose for the name of your class. Remember, the name of a class must be starting with an uppercase letter as a convention. For example, a header of class that represents the employee might be public class, and you see the keyword class over here, and the name employee, which as per convention in this context starts with the capital E at the beginning. The most liberal form of access is public. The keyword public, as you can see right here on line 2, is a class modifier. Classes that are public are accessible by all objects. Public classes also can be extended or used as a basis for any other class. Making access public means that if you develop a good employee class and someday you want to develop two classes that are more specific, like salaried employee and hourly employee, then you do not have to start from scratch. Each new class can become an extension of the original employee class, inheriting its data and method. Although other specifiers exist, you will use the public specifier for most of your classes. After writing the class header public class employee, you write the body of employee class between a set of curly braces. Let's go back to the code. So you have the class employee and the curly braces is open over here and then closed down there. And as you remember from previous videos, I said we will add a public static void main string args method to the class that we want to be executable. So what happens is the body of your class is going to go between this curly brace at line 13 with this curly bracket at line 2. Let's define an employee number, okay? So what I'm going to do is I'm going to define an employee number right here, and I put an access identifier at the beginning of it. I make it private integer emp number, and that's how I define it. The body contains the data and the methods of the class. The data components of a class are more often referred to as data fields to help distinguish them from other variables you might use. What you see here on the screen now is a data field. So data fields are variables you declare within the class but outside of any method. Remember, in this case, if we have a method here, the data field, which is employee number, is defined outside all the methods. So they should not be defined inside the method so that they be accessible by all the methods. Notice that in our example, the data field employee number is not preceded by the keyword static. It's very important to understand what the difference is. If the keyword static had been inserted here, like it was like private static integer, okay? If we were using this current situation that you see on the video, only one employee number value would be shared by all employee objects that are eventually instantiated. Because employee numbers should be unique to each employee, I'm removing the static word from here so that every single employee, every single instance or object gets its own copy of non-static data field. A non-static data field employee number is an instance variable for the class because one copy exists for each object instantiation. So as you can see on this slide, a non-static field given to each object is basically the way that we create the instance variable so that each object can have its own copy. You already have learned that the access specifier for most Java methods is public. However, most fields, such as an employee number in the employee class, are private, which provides the highest level of security. Assigning private access to a field means that no other class can access the field's value, and only methods of the same class are allowed to get, set, or otherwise use private variables of the current class. The principle used in creating private access is sometimes called information hiding and is an important component of object-oriented programs. A class's private data can be changed or manipulated only by a class's own methods and not by methods that do not belong to this class. In contrast to fields, which are usually private, most class methods are public. The resulting private data public method arrangement provides a means for you to control outside access to your data. Only a class's non-private method can be used to access a class's private data. The situation is similar to hiring a public receptionist to sit in front of your private office and control which messages you receive, perhaps deflecting trivial or hostile ones, and which messages you send, perhaps checking your spelling, grammar, and any legal implications. The way in which the non-private methods are written controls how you use the private data. In summary, a class's data fields are most often private and not public. The exception occurs when you want to use a non-changing value without being required to create an object. In that case, you make that field both static and final. Okay? For example, the Java Math class contains a final public static field named PI that you can use without instantiating math objects. You will learn about this in future videos. Okay, now it's time to talk about creating instance methods in a class. Besides data, classes contain methods. For example, one method you need for employee class that contains an employee number is the method to retrieve or return any employee's emp number for use by another class. A reasonable name for this method is getEmployeeNumber, and its declaration would be public integer getEmployeeNumber because it will have public access, return an integer because that's the employee number, and processes the identifier getEmployeeNumber. Let's head on to the code and add this method. So as I said, the identifier for this one is going to be public, and the return value is integer because employee number is an integer, which is going to be the return value for this method, and the name is going to be get employee number. And if you remember, we need parentheses because this is a method, and then curly braces, and then we go from there. So public integer get employee num. Because this method has a return value of integer, as you remember, it needs to return some value of type integer, which in this case is employee number. So looking at this is the basic public class that we can define over here. Similarly, you need a method in which to set the employee num field. A reasonable name for this method is going to be set employee number. And its declaration is going to be public void set employee number with an integer emp to be passed over there. Let's look at it. So it's going to be a public method as the access is going to be there. And the return value is going to be void because the role of this class is going to be setting the value of emp number. So there's not going to be any return value. And the name we decide for it is going to be set employee number. And now we're going to pass a number to this method to set it to the employee number. Therefore, we need to have an integer, and I just call it emp. And then as you can see, this method does not need a return value because the only thing that this method does is basically sets the employee number. In this case, what I'm going to do is simply set emp num to be equal to emp. So let's look at what's going on. So the emp is the integer that I will be passing to this method as an argument. And the argument is going to be assigned into the emp num. Methods that set or change field values are called mutator methods. Methods that retrieve values are called accessor methods. In Java, mutator methods are often called setters, and they conventionally start with the prefix set. Accessor methods are called getters, and they conventionally start with the prefix get. Using these three-letter prefixes is not required, but it's conventional. As you noticed, we had a getter and setter. Actually, let me go back to the code. So here you have your getter, okay, or accessor, and here you have your mutator or setter. Notice that unlike the methods you created earlier, the get employee number and set employee number, these do not employ the static modifier. So there is no static modifier like what you saw before. The keyword static is used for class-wide methods, but not for methods that belong to objects. If you're creating a program with a main method that you will execute to perform some tasks, many of your methods will be static, so you can call them from within main without creating any object. However, if you're creating classes from which objects will be instantiated, most methods probably will be non-static because you will associate those methods with individual objects. You can use either a static or non-static method with an object, but only non-static methods behave uniquely for each object. You cannot use a non-static method without an object. Understanding when to declare fields and methods as a static and non-static is a challenge for new programmers. To help you determine whether a data field should be a static, you can ask yourself how many times it occurs. If it occurs once per class, it is a static. But if it occurs once per object, then it is not a static. Let's take a quick look at this table. So in Java, static is a keyword. It also can be used as an adjective. Static fields in a class are called class fields. Static methods in a class are called class methods. When you use a static field or method, you do not need to use an object. For example, JOption pane that show dialog. When you create a class with a static field and instantiate 100 objects, only one copy of that field exists in memory. When you create a static method in a class and instantiate 100 objects, only one copy of the method exists in the memory, and the method does not retrieve this reference. Static class variables are not instance variables. The system allocates memory to hold class variable once per class, no matter how many instances of the class you instantiate. The system allocates memory for class variables the first time it encounters a class, and every instance of a class shares the same copy of any static class variables. Now let's talk about non-static. There is no keyword for non-static items. When you do not explicitly declare a field or method to be a static, it is non-static by default. Non-static fields in a class are called instance variables. Non-static methods in a class are called instance methods. When you use a non-static field or method, you must use an object. For example, system.out.println. When you create a class with a non-static field and instantiate 100 objects, the 100 copies of that field exist in memory. When you create a non-static method in a class and instantiate 100 objects, only one copy of the method exists in memory, but the method receives a this reference that contains the address of the object currently using it. Instant fields and methods are non-static. The system allocates a separate memory location for each non-static field in each instance. In this slide, you can see how public, private, static, and non-static class members can be used by another class. The figure shows a class named myClass that contains 4 methods that are public, static, private, static, public, non-static, and private non-static. The figure also shows a test class that instantiates a myClass object. The test class contains 8 method calls. The 3 valid calls are all to public methods. The call to the non-static method uses an object, and the 2 calls to the static method can use an object or not. The rest of the test class code after the documentation is invalid. Private methods cannot be called from outside the class, and non-static methods require an object. This figure also shows a typical class that would be used to declare an employee class containing 1 private data field and 2 public methods, all of which are non-static. This class becomes the model for a new data type named employee. When employee objects eventually are created, each will have its own emp_num field, and each will have access to 2 methods, one that provides a value for its emp_num field and another that retrieves the value stored there. Most classes that you create have multiple data fields and methods. For example, in addition to requiring an employee number as we did here before, an employee needs a last name, a first name, and a salary. Although there is no requirement to do so, most programmers place data fields in some logical order at the beginning of the class, as you can see over here. It makes sense to list the employee number first in the class, then employee's last name and first name together, so it makes sense to store those 2 employee components adjacently. Despite these common sense rules, you have a lot of flexibility in how to position your data fields within any class. What you have to be careful about is making sure it is readable for you and it's understandable for you and other people that are collaborating with you on a project. Because the current employee class has two string components, they might be declared within the same statement, such as I can just come up here and define employee first name, and therefore I don't need this line at all. So for you to be able to compare, I leave the line here as a comment. As you can see, I can define both of them at the same time while I'm defining string data types. So either multiple lines or just define them in the same line. It is usually easier to identify each employee field at a glance if the fields are listed vertically. So some people like to have it line, 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 line. And there is another school of thought to save some lines and just put them all within the same line. You can place a class's data fields and methods in any order within the class, as we said. For example, you could place all the methods first, followed by all the data field, or you could organize the classes in an order that several data fields are followed by methods that use them, and then several more data fields are followed by the other methods that they use them. Again, there is no requirement for this. However, preferences in the way you develop it is important in creating a readable program and a maintainable program. Within the same pattern, when you started defining your methods, which is right here, now you can define other methods like, for say, I'm going to go ahead and do the setters and getters for employee first name. So obviously, as we discussed, we're going to have these methods as public, and because for setter there is no return value, it's going to be void. Set a name like employee last name, and of course we're going to pass in a string to it, which is the name, and this method technically sets the string name to the employee last name. So that's going to be employee last name, if I'm not mistaken. That was the syntax we used, and then name is going to get assigned right over there. So that's going to be the setter for employee first name. So for the getter, this time it's going to return the first name, so there's going to be a return value. So it's going to be public string get employee last name, and this one does not need any entering value, and the return value for this one is going to be employee last name. Okay, so pretty much as you can see, these two getters and setters are very similar to the getters and setters for what we did before on the employee number. The employee class is going to have multiple getters and setters. Let me just add the ones for first name and salary pretty quick. And here we go. So what I did was I defined a get employee salary down here that returns a double value of employee salary. I defined the set employee salary up here, which basically receives a sal and sets the sal to be saved in employee salary. Get first name, same as last name that we had, returns the employee first name, and then set first name, which sets the name to be equal to employee first name. So as you can see, let me just clean it up a little bit so we have almost everything within the same realm, so you guys can see it all together. It's a good number of getters and setters, so we have 1, 2, 3, 4, and therefore we have 8 getters and setters. So the employee class is still not a particularly large class, and each of its method is very short, but it is already becoming quite difficult to manage, as you can notice. It certainly can support some well-placed comments. For example, we can put the purpose of each one of these methods beforehand. So remember, commenting is going to help. So like put a comment over here and say returns employee last name, and something in that realm, or you can just go up to the class and right underneath here just put the purpose of this class and so on and so on. So commenting here is very helpful for maintaining and managing the classes, especially if you're working in an organization. It's going to help everybody all around. Your organization might have a specific recommendations for requirements of placing the comments in the class, which in that case you have to look into what they have and consider what they have. So again, we started with defining the class employee. We defined the data fields over here or instance variables. Then we defined the getters and setters. We talked about access identifiers and modifiers. We talked about public, private, protected, extended, and all those. And we also talked about when to use a static and when not to use a static. So the logical next step is going to be talking about how to declare objects and using the methods on those objects. So let's go and discuss that matter. Declaring a class does not create any actual objects. A class is just an abstract description of what an object will be like if any objects are ever actually instantiated. Just as you might understand all the characteristics of an item you intend to manufacture long before the first item rolls off the assembly line, you can create a class with fields and methods long before you instantiate any objects that are members of that class. A two-step process creates an object that is an instance of a class. First, you supply a type and an identifier, just as when you declare any variable. And then you allocate computer memory for that object. For example, you might declare an integer as int some value, and you might declare an employee class as employee some employee. In this statement, some employee can be any legal identifier, but objects conventionally start with a lowercase letter. When you declare an integer as an int some value, you notify the compiler that an integer named some value will exist, and you reserve computer memory for it at the same time. When you declare the some employee as an instance of the employee class, you are notifying the compiler that you will use the identifier some employee. However, you're not yet setting aside computer memory in which that employee named some employee might be stored. That is done automatically only for primitive type variables. To allocate the needed memory for an object, you must use the new operator. Two statements that actually complete the process by setting aside enough memory to hold an employee are as follow, and you see them over here. So you either say some employee equals new employee, or instead of using these two lines, you just go with one line and call it employee identifier equals new employee. So whether you use these two lines to identify both of the steps or just combine them into just one line, you're going to have a new object with the memory associated with it. In this statement, employee is the object's type as well as its class, and some employee is the name of the object. Also, some employee becomes a reference to the object, the name for a memory address where the object is held. Every object name is also a reference, that is a computer memory location. The equal sign is the assignment operator. So a value is being assigned to some employee in the declaration. The new operator is allocating a new unused portion of computer memory for some employee. The value that the statement is assigning to employee is a memory address at which some employee is to be located. You do not need to be concerned with what the actual memory address is when you refer to some employee. The compiler actually is able to locate it at the appropriate address for you. The final portion of statement after the new operator, which is employee method, and has parentheses, looks suspiciously like a normal method name. In fact, it is the name of the method that constructs an employee object. So employee, as you can see it here, is called a constructor, a special type of method that creates and initializes objects. You can write your own constructor for a class, and you will learn how later in this video. However, when you don't write a constructor for a class, Java writes one for you. Whether you write your own constructor or use the one automatically created by Java, the name of the constructor is always the same as the name of the class whose objects it constructs. After an object has been instantiated, its methods can be accessed using the object's identifier, a dot, and a method call. Okay, let's see these concepts in action. So as you remember, my class is defined up here, right? So what I'm going to do is I'm going to go to the main method, which is where my program actually runs from. And what I'm going to do is I'm going to define an employee and name the employee clerk. And remember how the definition happens. So I have to assign memory to it, right? So employee, and this is how my first object of employee named clerk is being created. Let's create another one. So the data type first, the class name first, and then the identifier as we said, and then we allocate the memory to it, and here you go. So now you have another employee, and remember this employee over here. Let me just scroll it up a little bit so it can be easily seen. So this employee over here is nothing but the constructor of the class. Now that I have two objects generated, and let me just fix this typo. So now that I have these two generated, I can call their methods through name of the object, right? Clerk, using a dot. So I put a dot over here, and notice as soon as I click on I put the dot down, it gives me suggestions over what I can use and what I cannot use. Think about these: employee first name, last name, employee number, and employee salary. They're all showing a red dot. The reason for that red dot is because these are private members of the class and cannot be directly accessed from outside the class. Okay? And then you have these green methods over here, which the green dot is telling me they're accessible to me. So I can use any of those. So what I'm going to do first, I'm going to go ahead and set employee number, which is this guy, to 345. Very simple, right? And then the other thing I'm going to do is I'm going to get the driver, which is another object, and use dot, okay? And then set employee number for dot, and notice that when I have the suggestion, if I hit enter, it automatically fills in the rest for me. So I'm going to set this to 567, okay? And then what I'm going to do is I'm going to do a system, because I want to show you what we set, right? So what I do is a system.out.println, and what I want to do in println is I want to put down that the clerk's number is adding a space, okay? And then let me just do all these at once. And there you go. So basically the system.out.println does the clerk number is, let me fix it, okay. And look here, I'm calling the getEmployeeNumber method of the clerk, which is going to return a string to be concatenated here. And the driver's number is driver.getDriver. get employee name. Let's run this program pretty quick. And as you can see down here, it says the clerk's number is 345 and the driver's number is 567. This is as simple as you can have access to any method of an object of the class. Again, the name of the object or the identifier of the object, the dot operator, and then call the function. When you call the methods of a class or functions of the class, remember that the signature you're using here must match the signature that you have defined before. For example, for the set employee number, if I go back up there, you notice that this is set employee number, and an EMP integer must be passed as an argument. And here down, as you can see, I'm passing 345. Or for the driver, I'm passing 567. Those are integers, are being received, set to the employee numbers, and when I get it back, they actually come out and be shown. Okay, let's talk about the concepts of data hiding and encapsulation a little bit. Within the main method, we had to use the public methods set employee name and get employee name to be able to set or retrieve the value of employee number field for each employee, because we cannot directly access the private member employee num. And as you remember, when I was trying to mouse over those, they were showing me the red dot, basically messaging me that this is a private member, and because of the private access, I cannot access to it. So a direct assignment statement does not work when it comes to the private members. Data fields usually should be private, and a client application should be able to access them only through the public interfaces, that is, through the class's public methods. However, you might reasonably ask, when I write an application, if I can't set an object's data field directly, but I can set it using a public method, what's the difference? The field value is set either way. And you're right. And you're not. Actually, the set employee number method in the employee class that we developed before accepts any integer value you send to it. However, you could rewrite the set employee num method to prevent invalid data from being assigned to an object's data fields. For example, perhaps your organization has rules for valid employee ID numbers. They must be no fewer than, let's say, 5 digits, or they must start with a 9, or anything. The statements that enforce these requirements would be part of the set employee number method, checking the value for validity requirements and decision making over the input value. You will learn more about this in future videos. Similarly, a get method might control how a value is retrieved. Perhaps you do not want clients to have access to part of an employee's ID number. Or perhaps you always want to add a company code to every ID before it is returned to the client. Even when a field has no data value requirements or restrictions, making data private and providing public set and get methods establishes a framework that makes such modifications easier in future. You will not necessarily write set and get methods for every field in a class. There are some fields that client will not be allowed to alter at all. Some fields will simply be assigned values, and some fields' values might not be set directly, but might be calculated from the values from the others. So all in all together, using the architecture of setters and getters gives you more control in hiding information and managing input-output to your class. When you create a class, such as employee, and instantiate an object with a statement such as employee chauffeur equals new employee, you actually are calling the employee class constructor that is provided by default by Java compiler. As we discussed before, a constructor establishes an object. A default constructor is one that requires no arguments. A default constructor is created automatically by the Java compiler for any class you create whenever you do not write your own constructor. When the pre-written default constructor for the employee class is called, it establishes one employee object with the identifier provided. The automatically supplied default constructor provides the following specific initial values to an object's data field. Numeric fields are set to 0. Character fields are set to Unicode 0000. Boolean fields are set to false. And fields that are object references, for example, string fields, are set to null or empty. If you do not want each field in an object to hold these default values, or if you want to perform additional tasks when you create an instance of a class, you can write your own constructors. Any constructor you write must have the same exact name as the class it constructs. And constructors cannot have a return type, not even void. Normally, you declare constructors to be public so that other classes can instantiate objects that belong to the class. When you write a constructor for class, you no longer have access to the automatically created version. For example, if you want every employee object to have a default starting salary of $300 per week, you could write the constructor for employee class that appears here on this slide. And the other employee data fields will contain the automatically supplied default values. Even though you might want a field to hold the default value for its data type, you still might prefer to explicitly initialize fields for clarity. You can write any Java statement in a constructor. Although you usually have no reason to do so, you could display a message from within a constructor or perform any other task. You can place the constructor anywhere inside the class outside of any other method. Typically, a constructor is placed within other methods. Often, programmers list the constructors first because it is the first method used when an object is created anyway. You never are required to write a constructor for a class to make a class that compiles without errors. Java provides you with a default version if the class contains no explicit constructor. Let's head to the code and define a constructor. So what I'm going to do is I'm going to come back to our class, and on top of all these, I start defining my public constructor. Remember, we always want it to be public, and the name should be exactly same as the class name, okay? There you go. So as you see, this is the class name up here, and this name exactly matches employee constructor down here. Notice that we don't put any return value or anything extra on the constructor side. In this case, what I want to do is I want to set employee number to 100. So if anything, if you create an object, by default the employee number is going to be 100. And next thing I'm going to do is I'm going to set this line over here to be commented and this line over here to be commented. Okay, so basically I'm not manually set any employee number for these two objects. What I'm hoping is when I'm constructing the object, because I put the employee number set to 100 over here, the object will default to 100, and the message down here, instead of showing 345 and 567, show me 100 and 100. So let's run this, and as you can see, it says the clerk's number is 100 and the driver's number is 100. You can put anything you like in here. Let's try this. I'm going to put system.out.println, and what I'm going to do in that print line is I'm going to say a new object is created. So now you can see if I run this, every time a new object is created, it's going to give me that message. Let's run it again. And as you can see over here, I have two lines of a new object is created, a new object is created, which these lines are connected to line 43 and 44 when I set this, when I call the constructor. So in this case, you can even imagine this employee constructor is nothing but a method which is being called as soon as you use the keyword new. Okay, so as we discussed, you can do the same thing within the getters and setters. You can do controls, you can show messages, you can do anything that you like. So let me just comment this out. And what I'm going to do is I'm going to uncomment these guys over here so that they actually work and run the program again. And as you can see now, we have 345 and 567 as we used to have before. Pretty simple and straightforward. Okay, let's talk about how the classes are actually data types. The classes that you create become data types. Programmers sometimes refer to classes as abstract data types or ADTs. An abstract data type is a type whose implementation is hidden and accessed through its public methods. A class that you create also can be called programmer-defined data type. In other words, it is a type that is not built into the language. A class is a composite type. That is, a class is composed from smaller parts. Java's primitive types are not composite. Java has 8 built-in primitive data types such as integer and double. Primitive types can also be called scalar types. You do not have to define these simple types. The creators of Java already have done so. And finally, before we finish this video, I want to talk to you about some don't do it's. Don't place a semicolon at the end of a method header. After you get used to putting semicolons at the end of every statement, it is easy to start putting them in too many places. Remember, method headers never end in a semicolon. Don't think default constructor means only the automatically supplied constructor. Any constructor that does not accept parameters is a default constructor. Don't think that a class's method must accept its own field's values as parameters or return values to its own fields. When a class contains both fields and methods, each method has direct access to every field within the class. Don't create a class method that has a parameter with the same identifier as a class field. Yet, if you do, you will only be allowed to access the local variable within the method, and you will not be able to access the field. Remember, in action, and this is what you're going to learn in future videos, you will be able to use the same identifier and still access both values after you learn more about how to do it. But for now, make sure that the parameter in any method has a different identifier from any field. And with that being said, this video is concluded. Thanks for watching.